All right, let's get right into it. Today, we're going to connect the dots between a virus that, let's be honest, almost all of us will run into at some point, and a type of cancer that is, incredibly, almost entirely preventable. This isn't just a science lesson. It's really the story of your body's own hidden defense systems and, how we can give them a little help to win the fight. So this is the big question, right? How does a virus that's so common, we're talking about the human papillomavirus, or HPV, how does it sometimes kick off a chain reaction that ends in cancer? And more importantly, how do we stop it in its tracks? Let's start piecing this puzzle together. Okay, our story starts in a very specific, kind of microscopic place inside the cervix. It's called the transformation zone. Think of it as this constantly changing landscape, and it's pretty much the main stage where the whole drama of cervical health really plays out. So, the transformation zone, or TZ for short, picture it like a biological borderland. It's this active meeting point for two different kinds of cells. Now, all that constant turnover and regeneration makes it a real hub of activity, but it also makes it a little vulnerable. And that's exactly why it's the #1 spot for any issues to pop up. Now, this is super important. There are two kinds of changes that can happen here. Over on the left, you've got metaplasia. Just think of this as normal, healthy remodeling. It's your body just doing its thing, totally harmless. But on the right, you have dysplasia. And this is different. This is when the cells start to look abnormal, disorganized. This is the first red flag we're looking for. This is what we call a pre-malignant state. So, what makes the cells flip that switch from healthy metaplasia to worrisome dysplasia? Well, this brings us to the main character in our story, the intruder, HPV. Let's take a look at how this virus can sneak into those cells in the transformation zone and basically hijack their entire operating system. The way it hijacks the cell is actually dangerously clever. First, a high-risk type of HPV gets into the deepest layer of cells. Then, the virus unleashes these two little proteins, E6 and E7, and this is the critical move. E6 basically cuts the wires to the cell's emergency brake, a gene called P53. At the same time, E7 takes out another security guard, the RB gene. So, with both of its safety systems shut down, the cell can't die. It just starts dividing, and dividing, and dividing, completely out of control. And that is how dysplasia gets started. Now, while there are tons of HPV types out there, we're not fighting 100 different enemies. Get this. A staggering 70% of all cervical cancers are caused by just two high-risk strains, HPV 16 and 18. Knowing who the main culprits are is a huge deal, because it lets us focus our prevention efforts with incredible accuracy. Okay, so we've seen how the virus does its dirty work. And yeah, that might sound a little scary, but here is the really good news. This whole process, it leaves clues. And thanks to modern medicine, we have an amazing early warning system designed to spot those clues. Let's dive into how screening is so darn effective. This single biggest reason screening works so well comes down to one thing: time. This is not a fast process. From that initial HPV infection, it can take 5, maybe 10 years for a persistent infection to cause those significant cell changes we call CIN. And then it can take another decade, or even more, for that to potentially become invasive cancer. This super long timeline gives us this massive window of opportunity to find and treat things. So how do we actually look inside that window of opportunity? Well, we've got a great toolkit. The Pap smear, that looks for the effect, the abnormal cells. The HPV test, that looks for the cause, the DNA of the high-risk virus. And using both of them together, which we call co-testing, gives us the absolute clearest picture of what's going on. So, when should you be using these tools? Well, the current guidelines recommend starting screening at age 21. Then, once you're between 30 and 65, the gold standard is co-testing every 5 years. It's that simple, regular check-in that's the absolute key to catching any changes at their earliest and most treatable stage. And this, of course, brings up the big what-if question, right? What happens if a test comes back abnormal? It's a scary thought for anyone, I get it. But the whole point of screening is to find these things when they're small, and most importantly, when they're treatable. So let's tackle that what-if head-on. If a follow-up confirms dysplasia, it gets graded on a scale called CIN. Just think of it like a spectrum. CIN1 is low grade. It's only affecting the bottom third of the cervical lining. The risk of it ever progressing is tiny, like 1%. Most of the time, these just go away on their own. Your body is an incredible self-healer. Now, CIN2 and 3, they're more significant. They involve more tissue, carry a higher risk, and that's the point where your doctor will probably want to step in and do something.
So let me be absolutely clear about this. This is probably the most important message for anyone who gets an abnormal result. Finding CIN means the system worked perfectly. It means we found a treatable, precancerous condition, which gives us the chance to act long before cancer even enters the picture. It is not a cancer diagnosis.
For CIN 2 or 3, the most common treatment is a really straightforward and effective procedure called a LEAT. First, the area is completely numbed. Then, a specialist uses a very thin wire loop with a low voltage current to just remove the affected tissue. It's a pretty elegant solution, really. It's an outpatient procedure that both removes the problem and gives you a tissue sample to send to the lab, just to be sure everything's been taken care of. So far, we've been talking all about detection, catching the problem early. But what if we could go a step further? What if we could stop the problem from ever even starting? Well, that brings us to our ultimate shield, the HPV vaccine. Just look at this number, 90%. That's not just a statistic. It shows you the incredible power of vaccination and the scale of the global commitment. The World Health Organization has set a goal of getting 90% of girls fully vaccinated against HPV by the time they're 15. The goal here is huge. It's nothing less than making cervical cancer the first cancer ever to be eliminated as a public health problem. So how do these vaccines work? It's pretty cool. They basically show your immune system a harmless piece of the virus's outer shell, kind of like a mugshot. This teaches your body to recognize the real virus and fight it off if it ever shows up. The earliest vaccines went right after those two main culprits, 16 and 18, but the newest one protects against 9 different types, covering even more of the high-risk troublemakers. And when it comes to the vaccine, timing is everything. The perfect age to get it is around 11 to 12 years old. Why so young? Well, it's simple. The whole point is to build up a powerful immunity before any potential exposure to the virus. And it's for everyone, all genders, because HPV causes other cancers too. And vaccinating everyone helps protect the entire community. So we end up here with a new question. We've seen how the virus works. We know we have incredible early warning screening. And we have the ultimate shield with the vaccine. The tools to literally make this disease a thing of the past. They're right here in our hands. The only question left is, are we using them? Thanks for tuning in.